So now we are going to talk about the Van de Graaff generator, which basically generates a lot of charges on the surface of the metal, and it might reach thousands of volts. So basically, this is a mini Van de Graaff. It looks neat and cute. So basically, you can see here that this is a piece of metal on the top. There is a rubber here, rubber belt, that there's a motor inside that rotate this rubber belt, and when the rubber belt rotates, it starts to rub with a roller inside and take the charges up to the metal, and basically the metal absorbs the charges by contact. Then the belt goes back again and rub the roller inside, take more charges, and basically start to accumulate a lot of charges. And when the charges start to accumulate, you start to have higher voltages. You will know this later when you study the capacitor and how does it charge and how does it build the voltage. So let's see how this is working briefly. So basically, you have a motor here, a motor. This motor, this shaft, basically it has maybe a nylon roller, nylon. Then around the nylon you have a rubber belt. So there's a belt here that is basically, when the motor rotates, this rubber belt starts to move and rub or make friction with the nylon roller here. Okay, nylon roller. Then when this rubbing or this friction happens, it starts to basically take some charges and go up. When it goes up here, there's a piece of metal, a brush metal here, that touch here another roller, basically to hold the belt, so the belt is rotating. This metal shaft or metal brush, metal, it's connected to the sphere, the big sphere, the surface of the Van de Graaff, and it takes the charges plus Q and start to build the Q. The charges start to go up. Friction happens here, it absorbs by contact the charges, the metal here on the top builds the charges, and the voltage increases. And this is the idea of the Van de Graaff. I hope you got it. Thank you. So now we are going to talk about the Van de Graaff. And this is the only setup that we need for now. I don't need something else. So we will start to play it. You can see the rubbing belt is going, and if we went closer, we can see the roller inside getting some charges. So right now it's accumulating, and I'd like to let's see how it's going to happen. Oh, okay, I got some charges. I hope you have seen it. Let's make it closer. So you can see. So for now, let's use something like the key, which is this one. It's connected to the ground. We'll connect it here. And let's see what's going to happen here. Do you see? Have you seen this? Yeah, it's a big spark. This reminds you with what? If you know it, please write in the comments. Let it charge for some time and let's approach it. Okay. Let's turn it off and see something interesting right now. What's going to happen if we put, I like this, a cap for the Van de Graaff? What's going to happen? It's a plate, and see. Oh, it went away. Let's do something else. Let's add more caps to the Mr. Van de Graaff. Oh, it's going away. Let's add more. Many. See? Too many. On the top of the Mr. Van de Graaff. And let's see what's going to happen. Let's see. Oh, one's going up. Oh, the second, third. Oh, this is magic. So my question is, what happened here? Why they are going away from the top of the head of the Van de Graff generator? Think about it. I hope this has been interesting for everyone and you got something new that you learned today. Thank you. So now we've seen a very interesting phenomena when we put the aluminum foil. It's kind of fly away from the Van de Graaff when it's working. So why? I need you to think why this is happening. But let me illustrate why this happens. So when you have the Van de Graaff surface and you have the piece, the foil, the aluminum foil here, and they are contacting one another as we have seen. So basically, when the Van de Graaff is working, it starts to build some kind of a charge. Let's say a positive charge. So this positive charge starts to increase. And by contact, the positive charge to this side, yes? And when the Van de Graaff starts to accumulate a lot of charges, what happens? Here, the aluminum foil is going to have a lot of positive charges, which makes basically from the repulsive, clearly we're going to have a positive charge here, a positive charge here, and it's going to build a lot of repulsive force between both of them. So the repulsive force, which basically makes this one goes here and this one goes away. So the repulsive force is going to push the aluminum foil away from it due to that we have here a positive charge, and it starts to increase. And when the charges increases, what happens? The force or the repulsive force increases until it pushes the whole foil away from it. I hope this is clear to you. Thank you. I hope this has been fun to all of you and you've learned something new in the electrostatics lab. If you like it, please press like and subscribe for the next lab in physics 2. And if you have any question, please write it in the comments and I will answer it immediately. Thank you and see you soon.